I'm Jason Sarrafian with Stream-Flo, and we are here with the Stream-Flo of Consciousness Podcast. And today we have the pleasure of sitting with Matt Houde from Quaise Energy. And Matt's going to tell us all about the exciting things they have happening currently and on the horizon. So welcome, Matt. Thanks for making time for us today. There's a lot of things happening over here at the World Geothermal Congress in Calgary. But I think, first of all, we'll cover a lot of ground today, but I think principally, let's start off for the folks that don't know, for the people that are living under some deep, hot rock. Tell us a little about yourself. Tell us how you got involved with the project, maybe some background on how this got kicked off at MIT, all that good stuff.
Yeah, where to begin? So first, thank you for having me.
He's normally not a violent man.
Where to begin? So I did my undergraduate in geological and engineering and geoscience at University of Wisconsin. Pretty quickly, I recognized that the energy transition was exactly where I wanted to work in as a career. Started working on some research projects related to wind energy, and definitely was enticed to learn more about a lot of the cutting edge R&D that is going into all things energy. So I went to grad school at Stanford. And that was where I got my first taste of geothermal energy. I think it was by the second or third class I had with Roland Horn, who's a professor of geothermal reservoir engineering at Stanford, that I really recognized that this was a subject I was really excited by, really made use of the skills and knowledge I'd gained through my undergrad studies. And it was clear there was a lot of white space to improve the current picture where geothermal was today. Currently geothermal provides less than 1% of the current world energy consumption worldwide. That's despite the fact if you look at the energy stored within the crust, it's the most abundant source of stored energy, larger than any hydrocarbons by orders of magnitude. So
Exactly.
I was really excited by, okay, how exactly do we start to tap in just like a fraction of that? It could, power world civilization for thousands of years. I started doing more classwork in the geothermal program, although I wasn't officially in the geothermal program. I also interned with Format Technologies at the time.
Sure.
Got some exposure to what geothermal project development looks like from start to finish. And it was in my second year of grad school that I connected with a company, Quaise Energy, who had been at EGS for several years to that point. For the audience, Enhanced Geothermal Systems is where, very analogous to the shale revolution, we are repurposing hydraulic fracturing technology for creating geothermal reservoirs outside of locations where you have natural hot water or steam just erupting out of the ground. Alteroc had been looking at EGS for many years. They had come to the conclusion that to make the economics work outside of the areas that already have high geothermal potential, we had to go deeper and hotter, specifically with hotter going to super hot temperatures. This is a term that broadly covers accessing rock temperatures exceeding the critical point of water, which is around 374 degrees Celsius. This temperature frontier is really exciting, mainly due to the increased power density per well. Not only do you have increased enthalpy, or you can call it the energy being carried by that fluid as it comes to the surface, but at higher temperatures, you also have increased efficiencies in converting that thermal energy into useful electrical energy. And so from initial modeling and flow testing done by innovators like the Icelandics, it was already evident, back then that super hot wells had the potential to produce 5 to 10 times more power than the average geothermal well that's being installed today. Alteroc recognized early on that drilling was a key barrier to unlocking access to super hot rock at scale. It was really through that connection with Alteroc that I got connected with my co-founder, Carlos Araki, and Paul Waskoff, who was the researcher at MIT that had come up with a very novel way to drill. Paul had been working in nuclear fusion research for about 2-3 decades at that point. About 20 years ago, a pretty influential report, The Future of Geothermal Energy, was published by a researcher at MIT. And Paul, while reading that report, had this epiphany that there were technologies in nuclear fusion that could be repurposed towards deep geothermal drilling. Now, what are those technologies? It's primarily gyrotrons and waveguides.
Right.
In nuclear fusion research, a gyrotron is a high-powered source of microwave energy at millimeter wavelengths. These are wavelengths similar to 5G or the body scanner you go through at TSA in the airport. Gyrotrons are used in fusion research to heat plasmas to the temperature where a fusion reaction takes place. We're talking millions, if not tens or hundreds of millions of degrees Celsius. That energy is delivered to the plasma by a pipe called waveguide, which is a pretty
Right.
simple corrugated metallic pipe.
And is that your proprietary pipe, semi, or because I know that you've got, when I was out at Marble Falls, it was really interesting to look at that device, the waveguide, and how it's so specifically designed to carry these waves. Is that something that you guys have as your proprietary piece, or?
Yeah, I mean, I think there's definitely IP related to the
Yeah.
manufacturing, and certainly going forward as we go from shallow field testing to deep geothermal drilling, that waveguide will likely become more sophisticated and proprietary. But in essence, waveguide is very analogous to drill pipe. It's a conduit for, instead of fluids, high-powered microwave energy. Paul had the epiphany that using gyrotrons and waveguide, we could use microwave energy for heating rock rather than heating plasmas. And instead of talking millions of degrees Celsius, we're talking, 1 to 3,000 degrees Celsius for doing useful work.
Still pretty healthy temperatures.
Pretty
there.
hot.
Yeah.
To say the least. So Paul, got started on the idea about 15 years ago, doing initial lab testing, really validating the fundamental physics that you hit a rock with microwaves, it heats up, you can melt it, you can start to form a hole, securing some of the initial IP, which we hold a license to that patent. It finally reached a stage where it was going to be difficult as a researcher at MIT to bring in more capital to scale the next stage of research and development. And so in 2018, we, again, coming out of that Alterac connection, founded Quaise to be the commercialization vehicle for millimeter wave drilling. The way this technology looks in practice, again, is that we're generating high power microwave energy, the surface called a gyrotron, with a device called a gyrotron. We send that energy down the waveguide, which is our drill pipe, along with a purge gas. And that high powered microwave energy, once it hits the rock, will heat and rapidly destroy the rock through spallation, melting, or vaporization, any
Kinda
variety of
pulverizes it?
mechanisms. You could say pulverize, yeah.
Yeah. And is that gas what pushes the remnants back up the surface, or what happens after that?
That's right. Once we reduce the rock to an ash or cutting, is a term used in the industry, the gas is what we use to carry those cuttings up our hole for removal. So in that way, it looks very similar to air drilling.
Sure. Very cool.
Yeah,
Some crazy science fiction technology that you made science fact.
that's exactly right.
And so what do you have? So I understand you're drilling in kind of a different area. You're up in the volcanic areas of Oregon. What made you choose that location?
Yes. So a few years ago, we recognized that our vision for the company is that we didn't want to stay just limited to a technology license company or even a drilling provider and service provider. We saw the most value could be created by leveraging the technology to develop these super hot geothermal projects that would be at very competitive economics and through the drilling, accessible in a wide variety of locations. We started building a team and initially began surveying, where does it make sense to start developing super hot rock? We came to the conclusion that to minimize technical risk as much as possible, we really should choose a site that's very unique because we can access the heat at shallow depths.
Yes.
And because our team, owing to their past history with Alterac, had familiarity with the Newberry volcano site, I would say it was almost a no-brainer for selection. I mean, there's 2 companies operating at Newberry volcano right now.
And it turns out it's a little hot there.
It's a little hot, to say the least. We're talking, instead of 10 kilometers, drilling 3 to 5 kilometers, you hit 400 degrees Celsius.
But you guys are talking about ultimately going much deeper, right? 20 kilometers, something like that, if I'm correct?
That's the long-term vision,
Something
exactly
around
right.
12 miles-ish, for those of people playing in America,
That's right.
trying to translate. Do you feel that it will always be volcanic adjacent, or do you think that there will be other areas? Because, when I was visiting your test location last year, while just a sampling, it's a pretty small footprint you guys have, which is cool because it's just like plug and play, which, and extrapolating this out a little bit, being able to see these people and these other keynotes and like, when this goes forward, being able to provide energy to people that are in kind of remote places or kind of places where the typical drilling kit doesn't play out. I mean, do you think that you'll always be volcanic adjacent, or do you think there's other assets around the world where when you get that deep, that's going to be jackpot?
Yeah. So the answer to that is we do not want to always be adjacent to volcanoes. I would say that's very unique for the very first project.
Hmm.
And again, the reason for that is we're minimizing technical risk for all the technologies we're putting down in the hole. It also allows us to start development with conventional drilling. Conventional drilling does
Sure.
have the ability to access super hot temperatures. It's been done in Iceland. It's been done in the US. It's been done in several wells worldwide where traditional drilling will face increasing challenges is trying to access those temperatures at greater depths. That is where millimeter wave drilling becomes much more critical to project success. And so our goal with this project in Oregon is to develop our first super hot EGS project and power plant, demonstrate the competitive power production, unit economics, and importantly, also serving as a landing spot for the first commercial demonstration of millimeter wave drilling.
Right.
I think if we hit success on all of those fronts, that puts us in a position to now go to a site where we have to drill 5 to 10 kilometers. And now
Yeah.
it's going to be more challenging. It likely will also be more expensive. But the benefit is that the addressable market at those depths is an order of magnitude larger than going next to a volcano.
Yeah.
And
And the cost
allowing
will come down. Cost of scale. Yeah. As you
exactly.
grow out. Yeah. It's fascinating. Do you think that, you know, let's say 10 years from now, what part, if things go as you plan, what part of the energy market do you think super hot, super deep will be?
I think it can be very significant. I think right now there's clearly a lot of competition for having a source of clean baseload power. We're
Yeah.
talking in the US, this is hundreds of gigawatts, and worldwide,
Yes.
we're talking in the terawatts.
Yeah.
I think when you get to, if you look at hot rock energy, within the subsurface, just the thermal energy stored, I mean, there is more than enough energy to provide terawatts or hundreds of terawatts. But it's super hot, where we have the added benefit is delivering competitive unit economics in those regions without a high geothermal gradient. I think
Hmm.
that's really, to me, where the true promise of super hot rock lies, is that we can actually develop economic geothermal power generation in places today where it's an afterthought. And that's really our long-term roadmap over the next 5 to 10 years, is demonstrate that ability not just to bring projects online, but doing it at depths of 10 kilometers or deeper. Because again, that's where it's really going to make an impact for people all over the world.
So what are your biggest operational challenges in getting to that depth?
Yes, there's quite a few. I would say to start with, I like to summarize our technical challenges for the drilling as we have to get power down the hole, we have to get the stuff out of the hole,
Hmm.
and lastly, we have to keep the hole open.
Yeah.
So, a lot of our focus right now with the shallow testing, I think, is especially on those first two, because these are things we're trying to understand and model at shallow depths. When it comes to getting power down the hole, this is about transmission efficiency. The reason that we've chosen these gyrotrons and corrugated waveguides, very specific tools, when there could be a wide selection of ways we could, accomplish delivering directed energy downhole. The reason we selected that approach was because of the fact not only do we have a device that generates a lot of power, but we have waveguide that is suited to transmit that energy very efficiently over long distances, talking, less than 10% power loss over distances of kilometers. And so our goal as, an engineering team, of course, is developing that waveguide transmission line at the surface and the assembly that goes downhole to ensure not only are we transmitting that energy very efficiently over a long distance, but also that we can still do that as we want to curve the pipe such that we can drill
Hmm.
directionally, which is something, very important for
Yeah.
EGS and,
Yeah.
just adding to the challenges we have to
Next
accomplish.
level. So in your conversations so far, I mean, is it still at nascent stages, or, are there certain arenas that have shown more interest in tapping into this energy, whether that is for housing or whether it's for data centers or anything along those lines? Are you finding particular industries that have shown distinct interest in your technology as the way forward?
Yeah, I think we've gotten a lot of traction for power generation. I think, two areas that's coming from. There's definitely a lot of interest in rapid deployment of firm power from industrial companies and
Mm.
AI hyperscalers. I would say, in a bit of a longer term roadmap, there's a lot of interest from, utilities that want to see, if we can deliver the cost that we're projecting with increased economies of scale, accessing super hot as a baseload power source, clean or even not clean. Our goal is really
Yeah.
to make that energy cost competitive with natural gas or nuclear, or other sources of
Sure.
baseload
Absolutely.
power.
Yeah. I mean, Baseload is the end game, right?
Yeah.
For the most part. Do you think that, you look at a place like, and again, there might be regulatory issues, I'm sure, but like you look at a place like California where, you've got these big fires that burn down every 5 to 7 years. How much of an impact could you have there if they decide to let you drill on their property to then pull out this deep geothermal energy? I mean, I don't know if that's something you guys have looked at yet, specific to California, because they seem to have more of these problems than other places. And I know that they're starting to source energy from other states, but I would imagine they've got access to their own below the surface, no?
Yeah. I mean, California has a lot of geothermal potential. It's the host of the
Because
largest.
they've got a bunch of old school geothermal going on, right? I think
They
it's like
do.
half of their production right now, but
Yes. Yeah.
the
For the
modern
record,
geothermal where we are right now, yeah.
that's right. I mean, the geysers has been operating 50 plus years, if
Yeah.
I remember right. And that's the largest geothermal field in the world.
The OG.
The OG, exactly. I would say for Superhot Geothermal, there's a lot of exciting potential
Yeah.
that isn't necessarily deep. I mean, I think that the benefit of those shallow systems, although you are more regionally constrained, there's only a handful of these you can develop.
Right.
Those are always going to be, I think, for Superhot, the cheapest. They're going to be cheaper than
Because I
going
think
deeper.
most of those right now are like low, like 3,000 feet, something like that.
That's right.
Correct me if I'm wrong, but yeah, I think
they
that's
do not
somewhere
have
in
to
that
drill
ballpark.
deep to hit high temperature.
No, but it's a whole different beast. Yeah, it's been super interesting watching you guys for a while now. I know that, we were talking to some of your engineers a few months ago, talking about even hitting 1,000 F, but I mean, I feel like that's a little down the road. Given where we've seen the market move, especially recently, you guys thinking IPOs in your future?
Time will tell.
Yeah.
I would say in the next year, probably not. But,
Yeah, well, you never know. You never know. But I mean, it's a good place to be right now. I think that there are a lot of exciting things happening. What do you see? Do you see the test bed at Marble Falls still playing a role in other tests before you deploy them out to Newberry, or are you past that now and you think that we're just pressing forward?
Yeah, I think Marble Falls will continue to be a host, to be a test bed for doing things in the field. There's a lot of tests that we want to do to perfect the technology that are just very difficult to simulate in a lab-based environment. I would say, two examples. One is just going deeper, being able to verify our ability to drill, remove material, keep holes open over greater depths. And I would say, another aspect is learning to drill directionally. I mean, most of our wells drilled to date have been intentionally vertical. We've done the modeling to show this can go directional, and this is really important for EGS to drill wells in an orientation ideal for creating those fractures that connect multiple wells to serve as a reservoir. And so I think, Marble Falls will continue to be a valuable asset to us in terms of testing our technology.
Have you started to make tweaks to waveguide to be ready for directional?
Yes.
Okay, very cool.
Looking into it.
Yeah. And is that, I mean, are you finding challenges also with the other, you don't have to deal with drill bits, obviously, for the bulk of your process. I think, do you guys still use drill bits to base rock, or?
Yes.
Okay.
The approach in practice is that we don't want to replace or compete conventional drilling near the surface. I mean, pretty much everyone in this industry knows we've made huge gains in shallow drilling. And to us, that's a benefit because it's going to be cheaper. Exactly. So we're going to drill conventional, I'd say, as far as deep as it makes sense.
Yeah.
It's really, for us, what we want to address with millimeter wave drilling is that last, say, anywhere from 10 to 50, maybe 60% of the hole, where conventional drilling is starting to get very slow and where costs are piling up. Again, not just because it's slowing down, but especially because of increased non-productive time, replacing worn out drill bits, replacing damaged equipment. That's the depth threshold where we want our technology to come in and provide value.
So without giving away any secrets, I mean, in doing this whole process and building this business, have you also discovered, by building bespoke things for your company, have you discovered ways in which your technologies would wind up benefiting other industries, whether it's oil and gas or somebody else, because you're like, oh, this is a very useful function, useful tool. This could go into another space. Have you made other discoveries?
We've definitely explored intermediate markets, deep geothermal drilling. It'd be nice to make plenty drilling at, 1,000 meters than 10,000. I think part of the conclusion we came to is that clearly, like, the most value from what we're doing is going deeper for Superhot Geothermal.
Yeah.
I don't think any market application compares in terms of not just the value proposition our technology provides.
Sure.
in being differentiated, but also in what the market is, and where our technology could land. But we've explored applications in mining when it comes to mining exploration, having a tool that drills very small holes very rapidly, and we can characterize the ash we're producing to get a sense of, ore composition that could be of value. Looking at opportunities to improve production drilling. In mining, a lot of mining is still drill and blasting. You're drilling
Old
hundreds
school.
of wells, putting
Yeah.
dynamite in them basically, and blowing it off. There's a lot of interest in
Like a
reducing
Bugs Bunny cartoon.
exactly. Yeah.
Yeah.
And there's a lot of interest in reducing that energy requirement or drilling holes cheaper or faster. So we have looked at, mining and some other industries, but I think geothermal is really the most valuable.
Yeah, who do you think of the other, because everybody's out there trying the GGSs and AGSs. I mean, when you guys are successful, who do you think that there will be room for other geothermal technologies to run in parallel with you guys? Or do you think we're going to get to a critical mass where people just decide there's one way and maybe it's super hot, super deep? Or what do you think that the future holds for the space?
Yeah, I think in the near term, there is
Or
a
all
lot
boats
of
rise or something
right.
like that? Or
I think all boats rise. There's a wide variety of approaches people are taking to geothermal today, and I think they all play their part. I think companies like Ormat and Zanskar that are doing conventional geothermal, they're always going to have a place. Those systems, when they can be found reliably, can provide cheap baseload power, low technical risk. I think obviously, Fervo's, been a true innovator in EGS. I
sure.
think they're going to be around for the long term,
Yeah.
especially with the assets they have in a lot of the Western US. I do, feel my opinion that long term, we're going to drift towards a narrative that Superhot is the way to go. And that is because of the competitive unit economics. But I think, for now, there's plenty of room for us all to grow. There's so much demand that it's not a situation where there's a scarcity of how many geothermal projects can come online and us to be
Sure.
competing against each other. I'd rather have much healthier competition.
Absolutely.
And also
Yeah.
in a position where we all can share information that's valuable to, again, rising tide lifting all boats. There's no need for us, I think shale went through this where companies recognized that there was a lot more advantage to partnering together with sharing data, sharing technologies, learning from each other so everyone can bring their costs down rather than us all kind of keeping a closed silo around our operations.
Outside of drilling, you've also basically created a startup, right?
Mhm.
So what other takeaways from building this company do you have that you're like, I didn't expect this to happen, or I had to make these tweaks, or like lessons learned, or things you might be able to share with the audience too? You're like, this is kind of a cool way to do something else that's maybe not specifically drilling.
Yeah. A few. One, it's really hard.
Yeah.
Doing startups, especially in tough tech, there's so many ways things can go down and go under, and so many of them could have nothing to do with the success of your technology. But it's worth doing. It's so exciting, to get up and kind of have ownership of this problem I'm working on, I'm interested in, I know it is valuable, and I have certain freedom to explore in how we find solutions, not just for myself, but the team as a whole. I would say a more, strategic thing we've learned over the years is the importance of optionality. Often gets said, you want to have multiple
Yes.
shots on goal. And so any way you're designing your product development, your lab testing, the commercial vision or roadmap, you want to always make sure you're not constrained to one pathway where things could go wrong. You want to make sure there's always contingencies, side roads you could go down that maybe will ultimately get you to your end destination or serve as a pretty valuable landing spot. I mean, just as an example, with our drilling technology, we
Yeah.
have this vision of drilling 10 to 20 kilometers, which is admittedly crazy,
It's
right?
crazy, but I love it.
It is still things that could prevent us from not going that deep. But if we can get 5 to 10 kilometers, I mean, that is a healthy business providing hundreds of gigawatts online.
Yeah.
And so I think everything we approach for the strategic vision, technology roadmap, commercial roadmap, we're always thinking of how do we ensure we have this optionality built in.
Because you guys are tip of the spear on this. Like I've said before, last year at GTS kind of got about 20% of the wind in the room. And this year felt like 80%.
That's exciting.
I mean, that's just my outside observation, watching it happen, watching guys you have giving keynotes. You're here today at World Geothermal Congress, giving the speech this morning. How was the reception to that?
I thought it was great. Yeah,
Yeah.
I've had a few chats with people who really, really enjoyed it. I can always tell there's a few people, especially those more technically minded, who are, that sounds hard. And I agree.
Yeah, you agree. It's totally hard, but I think too, what's interesting is watching people who are not as dialed in, at least when I talk about it, I'm sure when you talk about it, and just seeing their eyes light up going, wow, that's some crazy availability.
Yeah.
Basing off of the numbers you mentioned earlier in the conversation about how much is out there to tap into. I know we're running low on time. Any other parting thoughts you want to leave to talk about Quaise and what you see as the future, or just for the space?
Yeah. I mean, I guess one I'd like to land on is, this idea of how do we get geothermal at the same terawatt scale the oil and gas industry operates today. I think I want to see geothermal on par with how we drill for oil and gas today. I think we have to find a way to bring that industry jumping headfirst into geothermal. And they've been involved for decades. They're clearly taking increased interest and involvement
Absolutely.
in geothermal, developing products, developing services. I know for a fact, for us to realize our vision of what we want Superhot and geothermal to be, we cannot do it alone. And I think the best way we can achieve that at scale is by getting the workforce, the companies, the capital from oil and gas flowing into geothermal. And I think Superhot is a way to do that. I think for those companies, when they see the economics and financial returns that are possible with Superhot geothermal, they'll realize that, wow, this just looks a lot similar to what we're doing today with oil and gas. Except, it could be less risk. It could be, more clean, all these other factors. And so I really want us, not just within Quaise, but as an industry as well, to push that collaboration together, because I really think that's paramount to how we unlock geothermal at this scale.
I concur. And I think the winds are right now, right? When you look at, there's other operators and vendors, investing in the space. Politically, at least in the United States, it's the only bipartisan energy source.
That's right.
The left has wind and solar, the right has oil and gas. Everybody's doubling down on geothermal right now. So it's a super exciting time. I want to thank you for taking time out to meet with us. I'm going to come around and give you one of these.
All right.
There it is.
Thank you.
Thank you very much. And yeah, we look forward to seeing what else you guys have coming up in the near future.
Hope to have some exciting
Appreciate it, Matt.
updates soon.
Yeah. Thank you very much.